All right, so today we're going to talk about sequences, and the reason why sequences are important is because if you can recognize a sequence, right, then you can figure out what's coming up next. You can figure out a rule to figure out what's going to come up in the next 100th time, or anything else that's kind of down the list, right? And that's really important when you're doing anything, right? Like, for example, um, if you can find a pattern, then you can adjust to the pattern. You can do certain things, right? Um, for example, even if you're going somewhere and you notice that every time you go down a certain street, it's always really crowded, right, at a certain time. And it's like, okay, that's a pattern. Like, if I know that's the pattern that's happens over and over again, then I can avoid it. Then I can go to a different street, or I can do something different. Like, we use patterns in our everyday lives, and so identifying them and being able to use them is definitely a good life skill here. Okay, so there's different kinds of sequences. We're just going to focus on this certain kind, little vocabulary word. If you can write this down. Um, arithmetic or arithmetic. Arithmetic sequence. Write that down, please. All right, so an arithmetic sequence is simply a sequence where you add the same number to the previous term. So what do I mean by previous term? So basically, how do I get from the one number to the next number? You add the same number. So here's an example that you can write down. Okay, so like, for example, 3, 6, 9, 12, 15. This is a sequence. This is what we call an arithmetic sequence, because you're adding the same number, 3, every single time, right? To get from one number to the next step. Okay. So when I say term, what I mean is this is like the 3 is the first term. Okay. Then the second term, then the third one, the fourth one, right? So this is the first term, then the second, then the third, then the fourth, then the fifth. Okay. So to get from the first to the second, you add 3, right? And from here to here, second and third, you add 3, so on and so forth. So this is the kind of sequences we're going to be dealing with, right? Real simple. Okay. Okay. So describe the relationship. And we'll talk about what that means to describe the relationship. So here's a list. So 8, 13, 18, 23, ... Okay. So describe what's happening here. Pretty simple, right? You can put in the chat if you want. What is happening in this sequence? How do I get from one number to the next number? What is my... Okay. Go ahead and put in the chat. How would I describe what's going on here? Right? Someone looks at it and they're like, what's going on? You would say, hey, what am I doing? Go ahead and put in the chat. Okay. Okay, good. Yeah, in the chat, I have got, yeah. So I've got, you can see it a whole lot of different ways, right? I've got, in the chat, I've got add up by 5. You're adding 5 each time, plus 5, adding 5. Yeah. So if you want kind of like I would say I'm adding 5 to the previous term is how I'm going to phrase it. Okay. But anything you say that adding 5 essentially will get you there, right? So how I describe it is I would say add 5 to previous term. Okay. And then what are my next 3 numbers? What are the next 3 numbers of my sequence? Right. You guys should be able to do that pretty easy. Go ahead and just fill in the next 3 numbers. Okay. On a quiz, if I'm going to ask this kind of question on a quiz, it'd probably be like, here's a sequence. What are the next 3 numbers? Right. So if we're going to add 5 to the previous term, so after 23 would be 28, then 33, and 38. And that's my next three numbers. Okay. So the mistakes you guys can make on these is just adding. So make sure you add correctly and don't get yourself all tangled up in there. Okay. Unfortunately, too many times I've seen people where like they know what it is and then they make like they add incorrectly and then they lose all the points, which is a little bit sad. Okay. Let's do another one just to make sure we got it. Okay. So describe the relationship here. We've got 0.4, 0.6, 0.8, dot, dot, dot. Okay. Can you describe the relationship and then do the next three numbers in the sequence? Go ahead and do that on your own. And yeah, you can put in the chat if you'd like. But again, I know these ones are going to be pretty simple, pretty fast. Okay. And one thing too is it's only an arithmetic sequence if you're actually adding the same thing every single time, right? Like if sometimes if it gets all messed up, if it doesn't happen, then it's not a sequence. It doesn't work like that, right? Okay, good. People are in the chat. Correct answer here. So we've got essentially add 0.2. That's our description, and our next numbers are 1.0, 1.2, and 1.4. Okay, so we check the math on that. Right. Oh yeah, on this one, I made it a little trickier with the decimal, so make sure that you're going up correctly, that you're adding these things correctly. Okay. Make sure you have the decimal in the right place. So again, even some people are like, this is so simple, Mr. Young. There's mistakes still to be made, so we still got to watch out and make sure we do things correctly. Okay. Okay. So let's move on. That's pretty simple. That's mainly the lesson, and this amount of stuff will get you through the IXL lesson for homework. Okay. So this is pretty simple here. Arithmetic sequences are just going up by that much. Okay. 1.0, so 0.8 plus 2 is 1.0. Someone was asking me a question about that one. How do I get up from that, right? So it's kind of like if you go 4, 6, 8, and then 10, right? If you add another, then it's just 1, and then 1.2, and 1.4. So you're just going up by 0.2, right? After 80 cents, if you add 20 more cents, you get $1. Yeah, some people put 0.1, but that's 1/10. That's way smaller than 0.8. Okay. So yeah, decimals make things a little bit more confusing. There might be fractions. Obviously, those are a little bit harder too. But there's nothing like changing denominator or anything like that. Okay, let's move on. Sorry, I'm answering a question in the chat. No. Again, going back to this, 1.0 and 0.1 are very different things. Okay, this is not correct. 0.10. This is not good. That's too small. You went back to 10 cents. So if you think about it, like you can make it like this: 40 cents, 60 cents, 80 cents, then $1. 0.10 is only 10 cents. So that's not good. That will not work. Okay. All right. Let's move on to where does the algebra come in? Okay. All right. Algebraic expressions. Okay, so how do I make this into like an algebra thing, like with variables and whatnot? Okay, so let's take this example here. 3, 6, 9, 12, dot, dot, dot. Okay. So here's the thing. We're going to try and make an expression. Remember, an expression we talked about yesterday has numbers and variables, and it describes the situation. So we're going to try and describe the situation using numbers and variables. So one thing you want to know is when we're talking about kind of like I did on this one right here where I said first place, second place, third place, fourth place, fifth place, we're going to use n for that. So n here's the first number, here's the second number, here's the third number, here's the fourth number. And the reason why we used n is just the variable of choice, okay? So we want to know what will happen in the nth place. So when n is 100, when n is 257, like what will it be? Okay, so when n is 1, when the first place, I get a 3 out. When n is 2, I get 6. When n is 3, so again, this is like third place, right? I get a 9. Okay, so here's the trick. It's not actually that difficult. I'm going up by 3 each time, right? So your instinct might be like, oh, it's easy. It's n plus 3, right, Mr. Leon? Not quite. If I was to do n plus 3, it'd be 1 plus 3, which is 4, not 3. It doesn't work out. So it's not, you might be thinking, oh, I'm adding 3. This is what I do. Okay? This doesn't work. If you plug in, for example, 2, okay, I'm sorry, this might be a little bit confusing. 2 plus 3, that means I should get 5, but instead I get the number 6. So this doesn't work. Okay? What you have to remember is repeated addition. If you add over and over and over again, you're actually multiplying. So my actual expression is going to be this, 3n. What? What do you mean, Mr. Leong? Well, let's think about it. What's the fifth number in the sequence? 3 times 5 should be 15, right? What's the sixth number in the sequence? Should be 18. Let's try it. 3 times 6 is 18. Okay, so that should be, that's right. What's the 100th number in the sequence? Well, 3 times 100 is equal to 300. So now that I've figured out the expression, this part right here, I can do any number in the sequence. I can figure out anything because I found out like kind of like the rule, right? You can think of the expression as like the rule. Let's see if you guys can try one. Let's see. So try to find the expression for this. There's an arithmetic sequence because we're adding by the same amount each time. What would be the expression? What would be the expression that describes this situation? If you have a guess, go ahead and put it in the chat. All right, I got some people putting it correctly in the chat right now. That's good. Anyone else have a guess? What would be the expression here? Yep, that's good. Okay, so we think about it, right? We're going up by 5 each time. So my expression is simply 5n. That's it. And now I can say, well, if someone said, well, what's the... basically what you're saying is this, like, oh, hey, I'm going to buy some, I don't know, chips at the store, and it's $5 for a bag. 2 bags would cost, 10. 3 bags would cost 15. I'm going to buy it for a big party of like all the students at Muscatel. So I want to know how many bags it would cost for like, 300. But because you have the expression, you could easily figure that out, right? 5 times 100 is $500. So, 300, sorry, is $1,500. So that's how much it would cost. So the expression helps us to apply it to any situation we want. Once you figure out the pattern, this basically you're finding out the rule. Okay, that's what the expression does. All right. Now again, this is not part of your homework tonight, but I just want to challenge you a little bit. This one I'm going to make a little bit trickier. Okay, what if I had something like this? This is just a little extra challenge. Okay, see if you can figure out what the expression would be for this one. Some of you guys are getting close, and you're like, oh, Mr. Long, isn't this the same as all the other ones? This one's a little bit trickier. A little bit trickier. All right, so a lot of you guys are guessing 4n, and that's a good start. But think about it, right? If I just had 4n, let's plug in my numbers here in red, right? These are my n's up here. Again, the n is just which like kind of place it is, okay? So you guys are right in that you're going up by 4 each time. But here's the problem. If I plug in 1 there, I only get 4, but I should get 5. Uh-oh. And if I plug in 2, I get 8, but I'm supposed to get 9. And if I plug in 3, I get 12, but I'm supposed to get 13. So what do I have to do to each of those numbers? Anyone have an idea? Right? So I get 4, but I'm supposed to get 5. Yeah, I get 8, but I'm supposed to get 9. I get 12, but I'm supposed to get 13. So what do I need to do? That's right. I need to add 1. There's my expression. 4n plus 1. Whoa. Interesting. I have actually always liked these because they're kind of like a puzzle. You kind of get to figure out like what else do you need to do to figure out the puzzle, and they get a little bit more quote unquote fun when they're a little bit more difficult, and you have to find a kind of different pattern and whatnot. Okay, so you're right. Yeah, you can add 1 when you need it. You can do whatever you need to do. You might need to add. You might need to subtract. But here's the key. You guys you're right when you said 4n. If you're still going up by 4 each time, you're going to do 4n. And then it's just about, can I add or subtract to get to where I need to be, right? So if I do one more here, last one. If I did, for example, 8, 13, 18, and 23, ... can you give me the expression for that? Anyone give me a guess what the expression would be for this one? Jeffrey got it. Jarek got it. Look at letter E for an example. Okay, for some of you guys who are getting close here. Yep, Jenny's got it. Alondra's got it. Yeah, once you get the hang of it, you're like, oh, these are pretty simple. I can do any of this. Okay, and again, you don't have to do. Yeah, Maya's got it. You don't have to do this actually on your homework. This is just extra. I want to challenge you guys a little bit. Okay. This is called writing an expression, right, for the sequence. All right, so you guys saw we're going up by 5 every time, so I know that's going to be 5n, but that doesn't get me there by itself. I also need to add 3. Right? 5 times 1 plus 3 gives me to 8. 5 times 2 is 10, plus 3 is 13. 5 times 3 is 15, plus 3 is 18. 5 times 4 is 20, plus 3 is 23, so on and so forth. And now I can predict any number, okay? Any number down the sequence I can predict, which is a lot better than actually having to write up by 5, up by 5, up by 5, up by 5. Okay, so let's recap a little bit. Again, an arithmetic sequence is just when you add the same number over and over again. To describe the relationship, you just add whatever that number is the previous term, and you need to be able to write these out, okay, the next 3 numbers in the term. Make sure you do your math correctly, okay? It's just adding, so when it comes up on a quiz, take your time, do it right. Okay. To write these expressions, if you're adding by the same amount, you're going to actually multiply. And the ones that are a little bit trickier, a little bit more fun, sometimes you have to add also. And as you can see, on this one here and this one here. All right, so pretty simple. Hopefully, yeah, hopefully that's pretty simple, and hopefully you can do a good job of filling in the sequences.